All right. Hi. Hello. Let me move my microphone. Hi. Do 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 do. Hello, Code Monkey. Hello, hello, hello. How are you doing? Welcome. This is the very rare early stream for me. It is 8 a.m. right now for me. What is it for you? Is this the best time for you to watch me or no? I have no idea. Okay. I'm going to work on the engine today a little bit. So, midnight. All right. Midnight might be a good time, depending on when you go to sleep, because I usually don't go to sleep if it's midnight. Absolutely not. Like, it is 8 a.m. for me, that it is morning, but it doesn't mean that I just woke up. It doesn't mean that I woke up today, even. All right. What am I doing? Yeah, so I'm going to work on the engine, right? I'm going to work on the engine, and the thing that we did last time was me working on the effect library, right? The algebraic effect system, but it ended up being a little bit different. It's not algebraic effect system yet. It's just a way of working with continuations in Rust. So I have been working on this a little bit off stream. I have renamed this into a different thing. I call this create shift resume. No, switch resume, right? Like previously we had these operations that were called shift and reset. This is what they were called in Scheme. I have decided to do a little bit of renaming here. I actually even published this on the crates.io. Switch resume. This crate does not exist. Huh? How does this crate not exist? Hold on, it is on crates.io. How much time is it required for it to appear on the docs? Switch resume. I have published this, right? Yeah, there you go. There you go. It was downloaded 4 times already by some bots probably. I didn't even download it myself. It should have been like built on the docs, but it's not for some reason. Okay, whatever. This is the way of us doing the continuations. If it's not on the docs, then I guess you can just open the local docs. This is weird. Hold on. Hello, Peter. How are you doing? 10 push-ups? Alright. Fine. Hold on. There you are. Person who does redeem that reward. You are one of the only ones. I think it's you and somebody else. I don't remember who else is doing this. Okay. ADB connect 37175 failed to connect. Of course failed to connect, because why does my device always get unpaired? I'm not sure. Hello again, do you remember me? X-Men lifts. Not really. These algebraic things you've been working on are still a little over your head? Alright. So this grade that I have published, for some reason it's still not built on the docs RS. This is this is more fundamental thing than the effect systems. It is a way of doing control flow, basically, right? And the effect system that like I was trying to do is like a combination of this control flow which requires like working with continuations and the trade system that we already have in Rust, basically. Kind of need to make some food now, but I will wait for the push-ups. Yeah, hold on, I'm just connecting to my phone. So for some reason I need to pair every time. I think maybe this happens when I upgrade my system. So like it's not connected anymore. When I upgrade my system, it forgets about all of the paired devices. Maybe. I was the guy who couldn't get a console. Found out the reason I was accidentally used an empty project instead of console window because I was my first project and I blindly followed the tutorial. Nice. Okay. So you got it working, which is all that matters, right? Pair. 37175 pairing code. Wait, hold on. Of course, hold on. The pairing port is different. This is so annoying. 5653. Why is pairing with my phone so annoying? And I need to do it every time. Every time the port is different. Every time the code is different. Okay, paired successfully. Nice. Now that we have paired, we can connect. Okay, there you go. Now we can do screen copy. So that we can see the thing, right? There you go. Here's my phone. We're going to open the camera. So we do the push-ups. Camera is over here. All right. Here's my hand. It's real. Okay. Strong push-ups. All right. I'm going for the push-ups. Right. There you go. Thank you for redeeming that reward and making me a healthier person. I mean, push-ups, they make you healthier, right? Is that how this works? I'm not really sure. But I think that's how it works, right? Okay. Now that we have done with this, we can continue. We can continue. Now do some push downs. Lay on your back and move your hands up and down. It's okay. I've been lying down for a long time. It's time to do some work. You know? You can sit down. Push downs are my favorite exercise. Okay. Let me show you this. So this is like basically a very simple, like very simplified effect system, basically, which is just like, I guess, yeah, this is like a way of implementing the effect system. It's a control flow mechanism. So we are over here. If we take a look at the example, we are running a task, which is like a function here, right? And we have this, so this was previously called shift. This was previously called reset, just like in Lisp. I have decided to rename this because I think this makes more sense. We're running tasks that we are able to switch the execution, like, so we're switching the execution into a different future, basically, is what we're doing here. So if you look at this code, right, we are running something that prints begin, and then we're switching the execution into another, like, future, which prints before, and then it's calling this resume thing. The resume is basically the thing that we have switched from, and we have switched from this function into this inner function, right? So resuming the outer function means printing end, and then we're printing the after. So like it's a way of doing control flow, which is a little like weird when you see it for the first time, but I think so. We were looking at wiki pages that explain the continuations not very well, right? If you look at the delimited continuation on the Wikipedia, this is not very this is not like super. I mean, there are some examples here, but I think this is still a little bit confusing. I think the thing that is less confusing that I have found is the continuation passing style article on the Wikipedia. So this is in functional programming. A continuation passing style is a style of programming in which control is passed explicitly in the form of continuations. So whenever, like, so think about it like this: instead of calling a function, you go into the function, and instead of so like returning from a function is basically calling the function, which is like continuing the thing where we left from when we called the function. You know, I don't know. You can read about maybe this article if the other two are confusing. Maybe it will make more sense if you're interested in that. Anyway, so like the reason I did all of this, right, is because I want to do a specific thing for my game, right, which was like working with transitions in the game. And I feel like we're getting close to it. I'm going to implement one more. If it's too hard to explain, it's too hard to implement. Well, actually, no, it's not. It was pretty easy to implement. The implementation is literally like less than 100 lines. Or, I mean, 100 lines is, I guess, more than 0. It's like 79 lines right now. And I did add a little bit of the things. I'm not sure if it's hard to... it's you know, it's like explaining the loops to the person who sees programming for the first time. Like, when you learned programming for the first time, did you get all of the concepts like functions and types immediately? It's like a thing that you have never seen before, so it requires a little bit of time understanding, I guess. I don't know. Would you consider Rust easier to learn for beginners than C++? Yes, I do think so. But if you are a beginner, I would think that it's a different... Like, I would start with a different language. I suggest people start with languages like JavaScript or Python, to be honest. If it is your first time programming. Okay. So yeah, maybe once we implement the thing that I wanted to implement actually, right? So like, why did I do this all once I actually implement it in the game? Maybe it will make more sense. Maybe. I don't know. You started with beater script. What is beater script? Hold on. Beater script? I never... A beater script? Editor for Pokemon Heart Gold? Huh? It's like a language, a programming language inside a game? Started with basic, but this was about 44 years ago. Be it. 44 years ago. I wasn't even born then. It's like the scripting language the game uses. I don't think the official name is known. Alright. Okay. So, yeah. Some time ago, I changed the way I do state management in my game engine from, like, building my state machine myself as, like, objects, right, into abusing, I would say, even, Rust async await. Because when you write an async function, essentially builds you the state machine for you. So yeah, we have this async state management over here. Here's our example, and yeah, in this example we already made the crossfading between things, right? And yeah. Yeah. That's how I had concepts like functions. So technically where you started, I remember not understanding the concept immediately. Lol. Yeah. Yeah. Whenever you find a new concept, it requires a little bit of time for you to get used to. So like one of the things that Rust introduces, for example, compared to other programming languages, is the ownership system, right? That's why Rust is harder to learn than other programming languages, because it's like a new ownership of pointers. Well, I mean, overall ownership and borrowing. I got the crossfade to work. Yeah, I did get. If you missed it, I can show you the thing that we have in the actual game, right? So in the link cider already, we have something. Link cider. Let's go here and let's just do cargo run. Let me show you. I guess yeah, so I started to show what I wanted to do. Whatever, I just discard this, git reset, and cargo run. So it's not just the crossfade. We did like a custom transition in the link cider where we are doing crossfade and zooming into the new state at the same time. We probably will change it into some other effect that Davey will think about, because Davey's the guy who is thinking about all of the graphical decisions here. But yeah, basically over here, so this is the inner level, right? I press space and I go into the inner level, and this is the transition that I'm talking about, right? So this is me like zooming into the other thing, right? It's a combination of a crossfade and zooming in basically here. So this is what we have. So this is working, but this is not working exactly as I want it to work, because right now, when I am transitioning into the other state, it's showing the transition, and while the transition is happening, I cannot interact with the game. And this is, it's not too bad, but I still want to fix it, because it would make more sense. So basically, I want the game to, like, be properly running, and so that I can play the game while the interaction is happening, even although this interaction in particular is pretty, like, short. One of the things that, like, let's say that we are transitioning into some sort of a, like, pop-up or something. Like, for example, I press escape to go to the menu, right? Where we can click like settings or like things like that. So I press escape, the pop-up with the menu shows up, and then I want to press escape again to go back, right? So right now, the way I did it is I cannot press escape 2 times in a row too fast, because the second one is going to happen during the transition, right? And during the transition, like right now, I am unable to interact with the game. So that's, for example, the reason why I want to fix this. I want to go escape. So technically, we are already in this new state in the menu, right? And I want to be handling like all of the things, like pressing escape to go back, right? So yeah. Does that make sense? I think it makes sense. Okay, I'm going to be working on the engine first though, before going into the game. I want to modify the example here a little bit. I'm going to try and continue working in Helix editor. Okay, so we have the async state, right? Async state example demo. There you go. This thing. So let me. This example is pretty. It's pretty long. How many is this? 420 lines. 420 lines. All right. Nice. Okay. Let me see. Where is the transitions happening, right? So this is exactly like we have in link slider already, right? So we are going into a different state. So we draw a transition before going into that state, and we draw the transition after going back from that state. So this could be like me showing a pop-up menu, or going into an inner level, or whatever, you know. So what I want here to actually happening, right, is let me try and think about it, right? So we are going into this other game state, right? We're going into this other game state. So I want to write here, basically crossfade into this, you know, crossfade into this. And then this finishes, obviously, right? Obviously this finishes. Once this thing finishes, it gives me still the thing that can be used to render. We do something like that, and then we basically we can crossfade. So over here, I want to draw a transition of me going back into running whatever I was running before, right? So this is where I want to use this continuation thing that I have been working on. So basically, I am going to crossfade into the current continuation. Does that make sense? So like I'm going to continue like executing this function. Continuing executing this function means continuing playing the current game state, right? So I want to continue the current game state while at the same time drawing the transition. I basically want to transition into continuing executing the function, right? Which means that I'm going over here. So I guess I need to edit as a dependency. But yeah, I'm going to do like I don't know, state something, switch, resume, async, move, crossfade. So I'm going to crossfade into the resumption. This resume object, what this means is continuing executing current function. Literally. So I'm going to resume with nothing. So over here I can provide the argument. This argument that I'm providing to the resume function is going to be like the value of this operation. Okay. So then what is this state? I guess this is I called it weirdly, right? So yes, I want to switch into drawing the transition, but what exactly am I switching, right? So the reason these things are called delimited continuations is because like this represents a certain task. It is not necessarily this function, right? It can be like, you're familiar with Rust async, like it's a task is what it is, right? Yeah. Okay, hold on. I actually think that it should be this context. What is this? This gives me events, this gives me frame buffer, and I think the context represents the state. So this should give me also the ability to switch, right? Switch self into the resuming. Yes, okay. You know what? Okay. Local box future. Local box future with the I guess this should be a generic technically, but I don't want this to be generic. So it should be, yeah. Man missing name members to do. Okay. Okay. Let me actually add that crate that I have made as a dependency. So I need to do async state cargo toml as a dependency. I'm going to have switch resume is what this crate is named. So there you go. And we have cargo toml over here. Workspace dependencies. This is my thing. It's going to be called switch resume 0.1. Okay. Cargo check. Package cargo. Okay. We're running with a Genghis extent example demo. Yes. That's what we're doing. Okay, the new crate has been installed. I think I need to restart my language server whenever I change the dependencies. Is that right? Code Monkey, you work in NeoVim. I think I have figured it out. Like one of the things that VS Code does, but Vim or Helix does not, is they do not like whatever needs to happening to the Rust language server when you change your dependencies, like restarting apparently, right? Needs to happen. Otherwise, it's going to not work properly. So yeah. Maybe that's why it was breaking for me all the time, because I'm like working on multiple crates and I'm changing the dependencies between the crates all the time. You know? Okay. So we obviously don't have the crossfade as a function, right? So yes, the transitions. Do 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 do. Don't think the LSP updates when you add a dependency on the fly. Yeah. So like I think in VS Code there's a setting that is on by default that it watches. Yeah, I think I remember. Like one of the first times I started working with Rust in VS Code, it literally asked me something about watch the workspace for changes. So that's something that is not happening in Vim and Helix and makes it less usable. Why don't they add the same feature that VS Code added? Like, you know, when I'm working on the engine, my engine consisting of a lot of different crates, right? So like it is changing a lot, which means that I need to restart it all the time. So it would be nice if it would just restart automatically. That's what VS Code does. Is TJ the creator of the Rust analyzer? Or of something? Or what? I'm not sure. TJ is a streamer, right? I think I have seen this name before. Okay, hold on. Transition. I think I want over here to still do not just this is just a convenience function, right? But the more generic one would still be getting async state transition. So this is a function. This is what I'm transitioning into, right? But what I'm transitioning from is literally from self. So it's kind of similar. It is kind of similar. Context mute self into and the crossfade. Mm-hmm. You did tree sitter and some LSP stuff. All right. Speaking about tree sitter, I think one of the features of Helix that I really like, and I feel like I'm going to use it a lot. I'm not sure how to do this in VS Code. Is like this incremental selection based on like the syntax of the language, right? So like if I want to select like this entire argument, go in between the arguments, right? Go into the like yeah, like this three-seater navigation and selection is pretty nice. Do you use it? Okay, I think this is how it should be working. So this is going to be a context. This method takes 0 arguments. Yes, switch. Okay, so switch over here. What are we switching to? We are switching into same stuff as switch resume. It should be the same thing over here. Switch. Yeah, the only thing that... Hold on. I want my context to be a dynamic trait, then this thing also should not be dynamic, right? I cannot have a generic function in a dynamic trait object, right? I cannot. I cannot. I guess it doesn't matter that much. Resume argument. Resume. By the way, did Gracio help ever reply to your request? I never wrote to them because we started writing the letter and then I discarded the letter because we thought that it would take more than 1 day for them to reply. So I just didn't send it, you know. Local box future. This returns nothing. I mean, this is going to return local box future also. There's a lot of like these things. Working without async in traits is a little annoying sometimes, but alright. So yeah, the switch interface is going to be something like this. So this means that we are providing as an argument to the switch a function that takes a future as an argument, and this function itself is going to be an async function. So we're returning a future. And this itself also returns a future. Too many futures. All right. So, and this future also returns nothing. I think this is the interface that I want. Pretty sure. Okay. Let's do it over here. Implement the context for the window. Should it be implemented for the window? Actually, it should not. It should not. So like in order to do the switch, we need to have a task. We need to have a task. Yeah. That's great. So it's going to be implemented for something else. It's going to be implemented for something else. This can be local future object. What is this? Remove. Switch. What about the lifetime here? What about the lifetime here? Well, it seems to me that this trait also needs to have a lifetime to it. For trait to be object safe, it needs to be to allow building vtable to yes, all right. The implicit elided lifetimes are not allowed. So wait, hold on. Hold on. Hold on, hold on. There's a lot of things going on here. Let me just not add the implementation of context for the window, because that is going to happen at a different point in time. So yeah. Yeah. The dynamic context. The trait context cannot be made into an object. Consider moving switch to another trait. Oh, why is that? Why is that? So this also has a lifetime to it, right? Because this is a generic. Yes, because this is a generic, right? In order for, yes, because this is, yeah, basically this is an async function within a trait, which means that I actually need to use the async trait or something. Let's do use async trait. Async trait. This needs to happen. Okay, fine. We're adding another dependency then. Async state cargotoml. This thing has async state as a dependency. Async trait. Okay. Since I added a dependency, I also need to restart my language server. Okay. So okay. So this is going to be async function switch. Instead of this being a future, we just yeah. So since I want this to be a since I want this to be able to be a trait object, I cannot have an argument which is a generic something that implements a function, right? So instead we do box in fn once. So we're taking as an argument a function that is going to be executed once. It's going to take as an argument the continuation, which is basically a future. This is going to return nothing. This function should return a future itself. There's a lot of boxing here happening. Whatever. This function itself, lifetime on that, and the function is going to return nothing. So just like that. Method defined here. Function defined here. Okay, so this this crate does compile. It's whenever we're using it. Okay, and then our transition function. So that's how it happened before. So the reason we could not interact with the game during the transition when it's happening, because we're using for the transitioning from and transitioning into, for both of those, we're using the active state. Active state is the trait that basically represents the state that is not interactable. It's only knowing how to draw itself. So what instead we're going to transition into is not an active state. It's going to be like the interactable state, which is literally just a future. That's how we have it. So it's going to be impl future output is t. So we can I can make it this generic, right? So this function is going to return whatever this into returns, basically. And then we need to figure out how to how to implement it too. So what was it before? I was just literally just drawing the transition until the transition is finished, right? And now it's going to be a little more complex than that. Going to be a little more complex than that. Context, we have a with frame buffer, yes. We have the events, probably even not the events. Probably not even the events. Maybe I want next event to be an async function. Next event self is going to return in window event. Just like this. So this is just me waiting for the next event. This is nice. Streams, whatever. Okay. Over here we're doing ttx next event. Wait. We are waiting for the next event to happen here, right? We are waiting for the next event to happen. So what it seems to me is that we need to establish a new context so that like context is what defines what we are rendering into and what is the source of the events, right? So because whatever I'm transitioning into needs to be drawn into a texture now, I need to provide the new context. So into context, into transitional context, because this context is only going to be used during the transition and like while the transition is not finished, basically. So into transition context is going to be something, right? I'm going to draw into a texture. So I think what we need to do here is I need to so the texture is going to be created here specifically. Context. Let's do this. Transition context. Texture is going to be ugly. Texture, new, uninitialized. Context. I guess we need to have a reference to something like it's too ugly, needs to be here at least. I'm not sure. Maybe the reference to the entire engine. What should I have here? I'm not sure. This one only has a okay, maybe a window. Self window. Because this create specifically only depends on the window. But I feel like I will have to make it depend on more stuff, maybe on the entire engine. Somehow. We'll see. I mean, for what I'm doing right now, all I really need is the ugly. Right? Transition context. Okay. So the context can get the ugly from there, and the size is going to be context with frame buffer f size, right? So we get the size of the current frame buffer. That's what we initialize our texture size to. Makes sense, right? So what is the transition context? Let's see, a transition context. It's going to be a texture. Texture. The texture. All right, there you go. There you go. Arguments to this function are incorrect with frame buffer. Okay, this cannot be this cannot be a generic thing too, right? This is a little, yeah, okay. Fine. Fine. I guess the way I can do this is let size be cell new vec2 split 1, for example, and then with the frame buffer size set to f size. That's how we can get the size of the frame buffer. And then we return size here. Does that work? std cell size. Yeah, okay. Back to this means that I need the use bad box LA linear algebra stuff. Okay. Expected mutable. Okay, yeah. So mutable. Back to use of undeclared. What do you mean undeclared? This because this is not listed as the dependencies again, right? Async state cargo toml adbox la workspace true. Okay, restart the language server. Right, should be working now. And we have size mismatched found. Yeah, okay, so like this is a little annoying, but all right, not too bad. Okay, so we're initializing the texture that we're going to render into in order to like have the transitional effect, right? Well, in fact, when we are rendering the state we're transitioning into, like every time we're rendering something, we need to render from and like combine those things, right? I think. So it's actually going to be more complex than that. Rendering into a texture is already happening inside the transition technically. I think this is not even needed. This is not even needed. It's going to be something else. It is going to be something else. One of the things is that so we are going to forward the events from this context into the new context that we're constructing, right? Okay. So we are going to have the reference to the parent context in context. Okay. Okay. So this is going to have a lifetime. It looks like, okay, maybe this is unneeded. Okay. Parent context is going to be context. That makes sense. All right. So we're creating this thing. Hold on. This doesn't make sense. Because there is no way we can pass this new context into this one. All right. Context with frame buffer. Ugly. And switch. All right. So I actually think that this is a little bit like wrong here. This So I have an async function which represents the current game state, right? And the frame buffer that we are rendering into it can change as we are like going forward. This means that this is technically not just the argument, like the context that has the frame buffer should not be just the argument of the async function. It should be the argument technically to the polling of that future. So and that makes it a little bit challenging. So yeah, what I want is a custom future context here, but this is not possible right now to do in Rust. So it's kind of similar to the Tokyo runtime. When you poll your future in Tokyo, it must be pulled from within Tokyo runtime, and I kind of have the same thing. So like there is a dependency for my async functions. They must be ran within the context that like knows how like where are we rendering into right now, you know. So this is not just the argument to all my async functions. This is the property of the executor of my async function. So as far as I understand, Tokyo Crate does this using the thread local storage, and this is not possible to enforce it at compile time, which is a little bit annoying, but okay. I think I need to try and use the same trick. So using the thread local storage, I have been looking into this a little bit. So we have this crate that is called scoped TLS. This is what I'm going to use, I think. So like specifically, what does this mean? Whenever we're polling a future, which is our game state, from within the executor, the game engine is actually being the executor for the thing, right? So whenever I'm polling my future, I'm going to set whatever we're rendering into to the window originally, right? Like so, like the future that runs directly on the engine is something that renders directly onto the window, right? But inside that future, we can establish new like context where we render into something else. That makes sense. That makes sense. I'm not sure if it's going to make any sense until I finish implementing this thing. Yeah, so I think this thing, the with frame buffer, this should not be the property of the context. The context is like, this is literally just like the task in my resume crate. Do I even need this trait then? Okay, hold on. I don't need this, I don't need that, I don't think so. So right now, when I want to render something, the only way for me is to render onto the window, and I need to provide the functionality to figure out where do we currently want to render into, right? And I think for that, I want to use this thread local storage because that's the only thing that I know. That's like render targets. Um, Well, I just have the this thing that's called frame buffer. Frame buffer can be a window frame buffer, or the or we can render into a texture already. I'm talking about like the other thing here. I'm trying to, as you can see from the title of the stream, I'm modeling my game state using async functions. And so let me just show you. So I have, for example, my game, right? My game code is literally written something like this: async function game, right? And over here, I want to, let's say, like draw a cube, right? And then later, I want to like draw a cube again, right? And the thing is, in between over here, something can happen that makes me want to draw into something else, you know? Does that make sense? So like, for that reason, my render target, right, which is like I'm calling this frame buffer. This is the thing that we're rendering into. It will not be the I'm trying to figure out which is the actual frame buffer. Yeah, kind of something like this, yes. So I think yeah, so like, yeah, that is why it's not just an argument to this function, because the frame buffer can literally change while I'm running my game, right? So I need to have a function that is called like with current frame buffer, right? And over here we have frame buffer, and we like draw a cube into this frame buffer, basically. Something like this is what my code is going to be, right? So this is why we already have this like with frame buffer a method. I thought it's going to be as a method on the context that we pass as an argument, but it looks like it's going to be something like completely separated. I'm not sure if I see a way of doing this as like an explicit argument. It's similar to the Tokyo runtime, you know? Tokyo runtime is like an implicit argument to your futures whenever you are trying to poll them. Does that make sense? Like, I don't think there is any other example that I can think about that is not Tokyo runtime. It is similar. It's very similar. Which is why we're going to use a similar approach, which is the thread local storage. So basically, there's going to be a function over here somewhere, which is literally going to be called with current frame buffer, right? F impl fn once from frame buffer. So this is going to call the closure with the current frame buffer. That's it. Let's say that it is generic t. This is going to return t, right? I need to add this crate as a dependency. Scoped TLS. What is the version? I think the version is 1. Yeah, version is 1. Okay. Sync state over here. Scoped TLS. Scoped TLS. Is it really that fast to like load that crate? Okay, I'm assuming LSP restart makes sense to do. Okay. So I'm going to have scoped thread local, scoped, hold on, it's called scoped TLS. Hello? Does this not work? Why can I not get the information on this crate? I don't know. Okay, whatever. Do, 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 do. So it's weird here. The thing that I want to have available for my scope is the frame buffer. The frame buffer is a thing that has a lifetime. I'm not sure if that is even possible. Static frame buffer. So what I want here is the frame buffer, right? And this thing has a lifetime, which is like over here. We also have this technically. Wait, does it work? It doesn't complain about this static to have a lifetime in it. Can I have just a lifetime? Well, let's see. Let's see. So I'm going to do frame buffer. Set to something. And then inside, we're going to have a function. Inside that function, I'm going to do frame buffer with and over here we're calling this with the frame buffer. Is that how it's going to work? Mismatch types, expected mutable reference, found irregular reference. Yes, that makes sense. That makes sense because so this crate apparently it only works with regular references, right? So I want to have a ref cell here. Is that what this means? So I'm going to have a ref cell over the frame buffer like that. And over here I'm going to do frame buffer borrow mute. Over here the ref mute. Something like that. Ref cell. No code actions available. std cell ref cell. No method deref mute. Because the deref mute is not in scope. Okay, we just do this then. This is probably very clear to you as you are used to all of Rusty and C even basic to you, but could you do me a favor? How many abstractions are you using in line 8 to 12 to get do call f frame buffer? Lines 8 to 12 over here. I'm currently writing this, right? So what exactly? So hold on. Actually, hold on. With current frame buffer. This is wrong. This is wrong. So this scoped thread local is going to be specified here in this specific function. I'm just using this thread local. I'm setting it to somewhere else, you know? Does that make sense? Expected item found, semicolon. Hold on. You're asking me about the code that I'm currently writing. Hello there, by the way. How are you doing? I'm trying to figure this out myself right now. Didn't scope threads land on stable recent-ish? I'm not working with threads at all. I don't have threads. I have thread locals, which is different. The reason I'm doing this is for the same reason as Tokyo runtime. Like I want to have a property of the executor of my futures, which is in case of a Tokyo runtime, like they have something to do with timers, I think. In my case, I have the frame buffers that I'm rendering into. A frame buffer seems a bit clearer, concise, to the point. Are you asking about the ref cell here? So we are using the inner mutability like thing here. So yeah, like basically we are moving the check. So like the frame buffer needs to be mutated, right? I'm rendering into the frame buffer, which means that the frame buffer needs to be mutated basically. But since this is basically a shared value, I need to make sure that only one thing is mutating it at a time, which like in this specific case with the thread locals, the only way to do this is move the check into runtime, which is this borrow mute. It is basically the borrow checker during runtime instead of during compile time. Seems to me there's at least function t impl once. Yeah, there's a lot of things here. There's a lot of things here. There's thread local storage, specifically the scoped thread local storage, which I'm using from this crate, which is another concept. But I think thread locals this is not specific to Rust. This is there in other programming languages. Scoped means that I'm going to be able to override it. So like when I'm rendering onto the window, I'm going to render into a temporary like texture that I'm going to use to render into the window, something like that. How am I today? I'm doing pretty well. I did a little bit of progress on my other stuff that we were doing last time, which was the continuations. If you remember that, I have published this as a crate. Is my docs already available or no? Let's see. Switch resume. This is the crate that I have. The requested crate does not exist. Okay. Docs RS are a little slow here, but I have published with this thing that I'm going to use. So this is the delimited continuations in Rust. I think that made it not too bad in terms of like trying to explain it, but let me try. Are you going to understand this or not? Let me try. Switch resume. Right? So still no fried brains. Anyway, hold on. So I didn't like implement the effect system properly, right? I only implemented the basic building block, which is me working with continuations. So what is the continuation, right? The continuation is whatever happens like after the current thing that you're doing in the function, right? So over here, for example, I'm switching the control flow from executing current function into executing something else. All right. So and inside this something else, I get an object that is called resume, and this is the current continuation or like the resumption, which in this specific case means continuing executing the current function, which is in this specific case printing the end. Does that make sense? It's a little weird, but if you think about it, It's not too... What is resume? Resume means that I'm resuming the execution of the current thing. Specifically, like I'm calling this function with a unit tuple, right? So I'm basically I basically, so over here we had a function. We had a function which was printing begin and then doing something and then printing end, right? So over here I have paused basically executing this function, so the end is not going to be like printed immediately. Instead we're executing this now, and this object represents whatever we paused, and we paused printing the end. So resume means print end in this specific example, and then after we have printed the end, we're going to print this thing. So like, it's a weird way of doing control flow. What is await? I guess if you don't, you can ignore await. You can just think about it as regular functions. But yeah, just implementing this on top of async await. If you're interested, I think I have found a thing that explains this a little more. Specifically, this is called the continuation, right? And the continuation passing stuff. I think this wiki page explains it a little better than other wiki pages. You can try reading this if you're interested. I think I'm getting closer to like explaining this myself, but obviously I still am not very good at explaining this myself. So I'm just going to ignore explaining. I mean, I'm going to try explaining this every time, but I'm not sure if I'm getting better at it or not. But well done, very clear. What's the benefit? Have you found it? The benefit. I'm implementing a very specific thing, right? I'm implementing a very specific thing for my game, which is the transitions. So transition is like the crossfade or something like this. Again, so we're back to the transitions, right? Hold on, async state. Let me show you this here, right? So basically over here, I want to have a function that is drawing the transition from the current thing into something else. Something else can be whatever, right? So in this specific example, I'm running like the same game state again from scratch, because this is a simple example, but this can be like so let's say something like this. We can draw a menu, right? For example, I press escape and a menu pops up on the screen, right? So this is me transitioning into the menu, right? And this is like right now looks kind of like calling a function, right? I can have a function that is called menu, right? This is just me showing the menu. So that's how it's already working. I am representing my game state as a function, specifically as an async function. So I will need to await it, right? But right now, like I can do this already, right? But in order to do transitions, I want to be able to like yeah, I want to be able to do transitions into this thing, right? So that this menu appears slowly, right? And then when I'm going back from the this menu, I'm going back into the current game state. Current game state is the current function that is running, right? So I want to transition back into running the current function. And in order to do that, I need to have the continuation of the current function as an object. Does that make sense? So that is what this mechanism allows me to do. I am using the current continuation. This resume is representing the remaining work left to be done by the current game state which is represented by a function, right? So this is the continuation of the function, which is, in this specific case, for example, it is a loop, right? So like the remaining part of the loop and whatever I'm doing after the loop, I don't think I'm doing anything after that, but anyway. So yeah, I have this continuation as an object, and I can use it to compose this object with something else by doing the transition. Does that make sense? I don't know. I have no idea. I think it makes a little bit of sense. How about a simulation game like autonomous agents in a world? A woman creature goes into a nursery and gets back home with a kid. Agent needs to sync behavior by others when they have an effect on how other agents look like. It needs to sync behavior by others and they have an effect on how other agents look like. Dark-haired woman into dark-haired kid. Would that be a simple system which highlights the altered and controlled flow? But would that be a simple system which highlights the altered and controlled flow, but complex enough to implement it radically smaller code base and less bugs, but also to allow new functionality that would be hard to get in the traditional code? Also exciting enough as there are many civilizations coders out there. I'm confused. I think whatever you are saying is more confusing than I'm saying here about my async stuff. Or maybe it's my brain, it's like not working at all at this point. But let me try. And at least, I mean, as soon as I make something that works, it doesn't matter if I can explain it or not, right? What matters is that it is going to work, hopefully. But there's a couple challenges that I need to do first, and one of them is like determining the current frame buffer that I'm rendering into. I was wondering if making a mini sims or sieve would be a great showcase for your continuations. I don't know. I don't know. Continuations are being used like by people to implement the effect systems, for example, right? Which is in turn being used to implement like async await, but I'm already using async await, so it doesn't really make sense for me to implement async await using async await. So I don't know. Right now I have one real world use case, which is the transitions, and I'm not sure if I can come up with a different one. But I mean, probably we will. Probably we will. At some point, I don't know. Okay, what is the problem right now? So this is the example code. For past couple of weeks, I started to learn Japanese out of the blue. Nice, nice, nice. I want to learn a new language. Why did you decide to learn Japanese? I think I'm not sure, but I think if I was to learn a new language, it would be Chinese and not Japanese. But I don't know. Okay. Okay, let's see. So this compiles. This actually compiles. Hold on. How does this compile? So I can specify something with a anonymous lifetime here, really? Interesting. Okay. Or does it not complain because I still have errors? Lifetime may not live long enough. To what? These lifetimes that are different? Do I even need a lifetime on that object? I'm not sure. I'm not sure yet. I literally just added this. Context. Just copied this from my crate. Hold on. You know what? Let me just remove this altogether. I think I should remove this altogether. Instead of it being a context, what even should it be? I think it should be nothing. So the context was there for me to know where to render from, but now it's going to be a runtime checked thing, right? As it happens today, I encouraged a Japanese guy on a court. He was able to speak enough English for us to greet and talk a few sentences. I was usually no Japanese, but it was exciting to tell I have spent time on basics like hiragana and katakana. Next, kanjis and vocabulary for everyday discussions. With Out of the Blue, I had no plans. I don't watch any anime, which would be a great motivator and source of material. Just thought it would be fabulous to understand 1/10 of local newspaper headlines. But to try a bit to know how hard it is. Yeah. Have you never learned another language? The only language that I ever learned is English. English is not my native language, as you know, right? But that was a long time ago, so I feel like learning a new language is fun, though. It should be fun. Just like learning a new programming language, you know? Ah, shit. This is hard, what I'm trying to do, though. Because I'm not really sure how to write what I want. Okay, so we're transitioning from this into this, right? Transitioning from this into this. So I'm guessing there should be a way of me introducing the new source of events and a new frame buffer, right? So let's start with just the frame buffer. Maybe not even the new source of the events. So I want to be able run with frame buffer. So I want to run a function with a new frame buffer. So for example, when I'm so that when I'm running it, it's going to draw into something else. I think it's how it's going to be. So f is going to be impl future. Output is t. This returns t. Okay, and I provide the frame buffer here. A mutable reference to ugly frame buffer. Actually, should it be a mutable reference to the ugly frame buffer, or should it be something else? Actually, you know what? When constructing the frame buffer, I'm constructing it from a texture, right? So, 2 foreign languages and 2 years of third, which I don't know practically at all. I dislike programming languages, but I'd love to push through to learn concepts they try to utilize or enable, like limited continuations you're exploring. Have you tried, have you tried Haskell? I think out of the all of the programming languages that I have tried, like I didn't do a lot of Haskell, but Haskell was the one that like introduced a lot of new concepts to me. And then Rust with its ownership system and shit. And I guess now I'm exploring this new world of continuations, which I think technically is there in Haskell. Haskell continuations. Continuation. There is a thing. Continuations represent the future of a computation as a function from an intermediate result to the final result. At its heart, call.cc is something like go-to instruction. It's like a very basic building block. You know? Is there... Whatever. I don't know. Maybe I should try actually writing something in Haskell. Okay. Okay. Run with frame buffer. So what do I want here even? I don't even want to construct the frame buffer once, right? I want to basically be able to provide the frame buffer on every polling of that future. Which means that so I have this function with current frame buffer. Let me see. So because the into needs to render into this new thing, it means that I do something like into is the future all fn context. So inside over here, I'm going to call the actual future, the context that I'm going to run. But before polling the inner future, I'm going to set the current frame buffer so that when I'm polling this, it's going to know what frame buffer to render into. Does that make sense? We are going to over here say frame buffer dot set into something, right? Set to poll cx. Infinite coder. Hello. As listed above, just your 4 lines of code has 20 different abstractions alone. Yeah. Then in ancient times, people were talking around who are walking around or using boats or on rivers. That's surprising. Russia is a large area where most are speaking at least Russian, huh? Now another thing about trust would be fair. Not get bogged down on having fight with mute frames, borrow mute, but call with frame buffer, but call successfully. Have you seen me implementing an effect system yesterday? I saw that you were streaming, but I looked into it a little bit. I was busy. Did you end up implementing the effect system? So then a question to you. If you were implementing the effect system, does that mean that you understand it very well? So here's a question for you. So, like, let's say that we have a Coca, right? In Coca, you have these resumptions, this continuation objects. They are present in Coca. So here's a question. In your programming language or in Coca, what is the effects of the resume function? Cannot find trait context in this scope. True. I don't have any contexts. Okay, so here we go. We are doing the implicit context where when I'm going to pull the thing that I'm transitioning into, I'm going to substitute the frame buffer with something else, right? No method named set for type U32. Wait, what do you mean? Oh, this is GL enum. All right. I don't want that. Set arguments to this method are incorrect. Like, hello, can Rust Analyzer be so kind and show me what are the arguments for this should be? Okay, let me start again. LSP restart. Are you going to work? Okay, it's working. Frame buffer. So I cannot how I'll do the. Oh wait, I can. Yeah, so frame buffer is scoped TLS, scoped key. Yeah, that's right. So set means that I can set this to something, and then f is going to be the function. Yeah, this is the function. Poll returns this. Yes. This means that this semicolon should not be here, actually, because I'm going to return the same poll. No method named poll. Yes, because I'm going to do let into is std pin mute. Pin. Should I like pin mutable reference to this so that I can poll my future? The future must be pinned, right? Into. Does this make sense? Poll. That poll exists. So how am I supposed to poll the futures manually? Rust manual polling of a future. Pin. Constructs a pin a mute t by pinning value t locally. So actually, I just need to do this, right? I just need to pin the into like that, and then I can pull it. All right, easy, easy. So now, now I want to over here to set the reference. So over here, I'm setting the I need to have the frame buffer set here that I'm going to render into. Right? All right. Well, I did a return and exception, nothing more yet. An effect of resume theoretically should be all effects a place where resuming. But we don't really have access to it. It might never return, but that's not how it works with Coca because it's probabilistic counting. Well, as far as I understand it, in Coca, the resume has no effects because your effects are going to be captured. It's like in my implementation, as you have seen it, we have specified the effects as explicit arguments of a function, right? And those functions, they are going to be captured in the resumption. So like your resume function like has the effects like inside of it. Does that make sense? So that's why when you're calling the resume, you don't need to provide the handlers for those things that are going to happen when you resume, you know? But that also is limiting, as I understand, I think, right now, because sometimes you want those things to not be captured. But it's kind of weird to explain. Dynamically, yes. Sometimes it is a dynamic, like, so sometimes when you resume your thing, you want to change the handler. And as far as I understand right now, when you are like calling your resume, it's going to be resumed with the same handler that we had before, right? But sometimes you want to change the handler. Specifically, what I'm doing right now is so technically my function here that I'm doing, right? So this is my function that represents the game state. My game state has the effect of rendering on the screen, right? And because I want to like draw this transition right now, right? I want to change where the game state is going to be rendered into. So like by default, it's going to be rendered on the window, but while the transition is happening, I want it to be rendered into a texture so that I can compose it with something else. So I want to change the handler of the render effect, basically. And that is something that I think Coca is not providing. But that's not the problem with Coca. What was wrong with Coca again? My biggest problem with Coca was that it does not have the ad hoc polymorphism. Do you know what this is? This is basically means the traits. So it doesn't have the traits or type classes from Haskell. And I'm not sure how to like. I mean, I don't know how to work without those. As far as I understand, it doesn't even have the interfaces from languages like Java or C++. So like, how am I supposed to write generic code then? For my dynamically typed checked programming language, it's not a problem. What exactly is not a problem? I mean, I am doing dynamically checked like rendering right now too, right? But like, I mean, I want this to be statically checked. This is an implicit property of, so when I'm executing my async function, it should be executed into in a context that knows where it needs to be rendered into. There is no way of specifying this. I totally understand. Hello, Davey. How are you doing? Did you do any progress on the game? No? Oh well. Hopefully I do some progress at some point. I mean, I'm working on it, right? I'm working on the game technically right now. I'm making I'm still working on this like system for doing transitions in the game. Okay, so over here, when I'm polling, I want to create the frame buffer, right? So over here, I'm going to do let mute frame buffer is going to be ugly frame buffer new color. Sure. This means that I need to reference to the ugly here. Okay. And over here, the texture. Okay. Yeah, so basically every time we are going to do the rendering, we're going to construct the frame buffer so that we can render into the texture. That's why I'm doing this on every polling. And then the texture. And the texture, it might be having a wrong size here, right? So let's see if we have the correct size. So we have the current frame buffer already, right? Frame buffer with, or rather with current frame buffer. Frame buffer size. So this is the size that we want. Size is this. So I do if texture size is not equal to size, then I want to recreate the texture. So this means that like I'm basically rendering into the texture that is the same size as my like window, for example. If I resize the window, it's going to be resized the texture too. Also, why do you need shift reset? That part is unknown for me. I think I have explained it before, but okay, sure. Let me explain this more and more. The more I explain it, the more I understand it myself, right? All right. Async state example. All right. I want to draw the transition, right? And I want to draw the transition into the continuation of the current function. That is why I want shift reset. By the way, I renamed shift reset into switch and run. So like this was called shift before. So basically I switch the execution from executing the current function into executing the transition. And instead I get the resumption, the continuation of the current function as an object that I can use to compose with something else. So I'm composing the continuation of the current function with like with the state that I came from, so that I can draw the transition. Does that make sense? So like I need shift reset, or I call it switch, to get the resumption object, because I want to compose that resumption object with something else. That is why. So like the resumption is the continuation of the current game state basically, and I want to have it as an object, as a value. Okay, so there you go. I am making sure that my texture that I'm rendering to has the same size as the actual frame buffer, and then over here I'm doing this. And then we have the problems with lifetimes. This makes some sense, but I thought there is another way of doing this. Okay, sure. If you, yeah, there is another way of doing this, but another way of doing this is not very nice. It's like there is another way of writing async functions in Rust. In like there is literally this thing that I'm like having here, like poll fn, right? Because what is an async function? It is basically creating a future. It is transforming your function into a state machine, which does different things depending on the current state when you're polling this object that is being created. So there is another way to write async functions, but the reason async await syntax exists is because it's easier to write the code this way. It's easier to reason about what's going to happen when you write an async function compared to like this stuff. You mean another way with the effect system? Yeah, sure. If you okay, sure. Just make it. Maybe you're going to come up with a better approach that I'm trying to come up with here. Sure. Okay. Let us see. What is the problem here? Lifetime may not live long enough. Closure implements fn mute, so references to captured variables cannot escape. Do I need to move here? No. Hold on. Hold on. Let me see. Captured outer variable. So I'm capturing this into, right? Is that correct? That's the problem. Oh wait, well, what is this? Cannot move out of into a captured variable. Variable moved due to use in closure. Move occurs because into has type this, which does not implement the copy trait. Into is moved here. Yes. So the pin does not implement the copy trait. Can I be a crab? I think you are a crab, edible monad. Hello, hello. Everyone is a crab. Unless you have a custom skin. Like some people. Hello, how are you doing? So you were streaming earlier today, I think, right? Where did your stream go? Consider adding move keyboard before the next closure. Move. I don't want to move this there, though. No, hold on. Hold on. In order to pull, I need to move? That doesn't make sense. Doesn't make sense. Hold on, we have pins. So if I have a pin, oh, I can pin a feature. I need to do as mute. Is that right? I want to do as mute here. Mute. This is a future. Pin the future so it's gonna. Yeah, I think this is the problem. I need to. Before polling, I need to do as mute. And then we still have a problem. 20k points for custom skin. Redeem idea. Yeah, I'm sorry, I'm too lazy. Like, I made this overlay a long time ago. And like, I want to make it better, but I want to work on other things. I was struggling with a very similar problem in Rust on stream today. A very similar problem to what I have, to what I am doing here. Interesting. What is your problem? Do you understand my problem? Anyway, we have we must do the push-ups. We must do the push-ups. So here's me going and doing the push-ups. I don't understand your problem, but I had a very similar looking error messages. Oh, all right. Are you doing async? Are you pinning your futures, or do you just have the issues with lifetimes? That happens. That happens sometimes. I think usually it's pretty easy, but I'm doing some weird stuff here that requires more thinking than usually than your usual Rust code, I think. I don't know. If you don't want to have problems like this, don't do async. working with Rust that is not async is pretty simple, I think. What are you building anyway? So I'm trying to build a game, but right now working on a way of doing transitions easily and representing my game state as async functions, and like trying to make a function. So this future over here, this is basically a game state, right? This represents me running the game. So I'm composing the future, which is me running the game, with something else. So this future must be rendered onto a texture so that I can compose it with something else. So that's what I'm doing here. I'm trying to substitute what we're rendering into with a texture, instead of it being a window or whatever we are currently rendering into. Don't do async, use effect system language and effects and is that. No, just use regular Rust code. Effect system is nice in theory, but have you actually tried it? I did not. So it is a research area for now. Effect systems for the worthy. Oh, since your name is Edible Monad, have you done effect systems in other languages before? Not a lot of languages have effect systems, especially if you only count the mainstream languages. Texture does not live long enough. Does it not? Played around with Coca a bit, but only on the surface level. Yeah. Same. So it looks very interesting, right? This idea of effects. So this, I tried implementing this in Rust, this system. It got me into, like, trying to understand the continuations and stuff. So in order to do the effect system like you have in Coca, you need to have this resume object, which represents the resumption of the current function, right? So this is the thing that I have actually implemented as a crate that I can build on top to theoretically build the effect system, but this crate still does not exist on the docs for some reason. But yeah, I have implemented something that is called delimited continuations. Think in Rust using async, so that I can refer to the continuation of the current thing as an object, and I'm going to use that to do my composition for the drawing, for rendering the transitions in the game. But it is hard. It is hard. Texture does not live long enough. By the way, I'm porting some C code to my programming language for a game. I'm porting mistyped SL. Yeah, well, good luck with whatever you are doing. Not sure what you are porting, but good luck. This requires that one must outlive static. Considering a move keyword. Texture does not live long enough. Borrowed value does not live long enough. I think what this means, hold on, I think I understand. So since this is a static thing, since this is a static thing, this means that whatever lifetime you specify here is going to basically means the static lifetime. But I want this to be not a static. So this is a little more challenging than I thought it's going to be, because my frame buffers, so like frame buffer represents the object that I'm rendering into, right? And since my texture has a lifetime to it, this frame buffer also has a lifetime, because frame buffer is like a reference to the texture that I'm rendering into. And this lifetime is not static, right? That's why we have this error message that the texture does not live long enough. It's trying, yeah, it definitely does not live for the static lifetime. Type nix shell psl run sl. No, I will not type that. I will type instead nix shell, no, nix run, nix packages, sl. This is easier than your nix shell stuff. You just do nix run using flakes. Okay. Why is it called SL? What is SL standing for? Steam locomotive? Alright. Nice. The program should be called Choo Choo. Okay, so I'm using this scoped thread local. Since this is a scoped thread local, I would assume that we would be able to give it something with a lifetime, right? But maybe I cannot. So over here, this thing, we already are setting this to a reference. This reference obviously has a lifetime. So okay, I have another option then. So like frame buffer because this frame buffer that I'm having, it has a lifetime that I'm unable to represent as my like, because everything that is static is going to have this static lifetime on it. What if instead of this being a ref cell, I am going to store as my static thing actually a function? Can I do this? This is going to be a boxed. Hold on. Does this thing needs to be sized? I want to do din fn mute ugly frame buffer. Can I store this? The size for values cannot be known at compilation time. Yeah, I don't think I can store an unsized thing here. So I will have to box it. That is okay. The problem with the boxed is that this box still needs to have a lifetime. Shit. Hold on, is this impossible, what I'm trying to do? Is this impossible, what I'm trying to do? I think, like, so the texture itself does not have a lifetime, though. The texture itself does not have a lifetime. Never pressed. I have a cell installed, I type it all the time when I try to do ls. I think I never type ls, I just type l. This is the alias that I have. I don't type ls. L is ls. Oh, actually I'm using exa. Exa l. This is what it is. Stupid lifetimes. All right, hold on. I mean, it's not stupid. I would like can. All right. So like technically, the thing that I'm storing inside the thread local over here, I'm storing the reference to it. So I'm storing inside the thread local something with a lifetime, but I'm only storing a reference. So the only thing that has a lifetime is the reference itself, but not the type of this thing. Is that right? Lifetimes are stupid. Finally, someone says it. No, they're not stupid. I mean, they are not smart enough. They are better than if they were not there. Lifetimes are stupid. No, I mean, they are not stupid in a sense that they should not exist. They are stupid in a way that they are not smart enough. You know. Let me take a look at the repository here. What about the issues? Lifetime static required. Yes, exactly. Okay, there you go. I am getting lifetime error when I try to use it. Cache is cache, right? So they are trying to store something in the thread local storage, which has a lifetime in it, right? I was going to submit an issue for related feature request. Right now, the macro only allows to store references where t is static, but it would be great to allow it to store arbitrary t8 instead. I'm guessing this would be a break and change for the main macro, but perhaps worth it. Okay. Did anyone came up with a workaround? Like I can I Okay, I think I know one of the solutions. So instead of storing the frame buffer itself, I'm going to store the texture that I'm going to be rendering into. Can I do that? I think I can. So like frame buffer texture is going to be a static ref cell of a texture. So this thing does not have a lifetime. So I'm going to be okay, right? So instead I'm going to do here frame buffer texture. Ref cell. I mean, it's going to be an optional. ref cell. So basically, it means that I'm either rendering into a texture or I'm rendering directly to the window, right? How long am I programming Rust for? Like 7 years. Hello there. Right now, like I'm trying to implement to do something like very advanced, I would say. That's not like the code that you usually writing Rust is easy, but what I'm doing right now is hard. I'm doing Rust for 4 months now. Nice. I don't know if that's easy. Started since 1 month, pretty difficult. Well, yeah. The first month was in the first month of Rust, I didn't write any code. I was just reading the book. So yeah. Coming from Java world, so low level never considered. Well, Rust is both higher level and lower level than Java. So you can... it's not necessary to go into the low level stuff. Like you, for example, I'm not sure what you're trying to do, but most likely you never need to use unsafe code. So like you shouldn't even probably look into that. You can only do some high level stuff. What is your goal? What is the kind of apps that you're making? I'm trying to do game development here right now, implementing some weird stuff. The transitions between game state is my current goal. So I'm currently representing the game state as an async function, and I want to make those things composable so that I can do the transitions between them. And it is a difficult task. Even what Kuvi is doing is already done. Of course it's already done, but I want it to be done differently. Everything has been done before, right? For people who like SL-LAF. SL-LAF. What does it do? Let's see. Unrecognized flag-L. I guess this. Help, help, help. Sometimes it's fun, good learning experience to do stuff yourself from scratch. Yeah, I agree. I mean, the way I learned Rust itself is so like I'm making games with Rust. I have my own custom game engine. The way I learned Rust is by implementing that engine. You know, I like doing stuff from scratch. No method named borrow mute. Okay, so frame buffer texture, right? So we have the texture. We're either rendering into a texture or into a window. So I'm going to have a window as another argument of this function, and I'm going to say that if I'm going to match the texture, right? And if it is a texture, then we do one thing. If it is not a texture, then we do another thing. So another thing here means if we're not rendering into a texture, this means that we're rendering into the window directly, right? So this means that I'm going to do window with frame buffer F, I guess, right? Window with frame buffer. With frame buffer, this function is not generic. So I'm going to change it into being generic. T, this function returns T and this returns T. There you go. Just remove the semicolon there. And we go into the backend and make this generic too. And remove the semicolon. Okay. Window backend web. So for the web backend, I need to do the same thing. With frame buffer, this thing, right? This means to be generic. And then we remove the semicolon, right? This is a better API, I guess. If you want, you can take a look. Into your implementation of the of this Steam locomotive. Okay. So yeah, if we are not rendering into a texture, then I'm just literally rendering directly into the window, right? So that's what we have here. And if we are rendering into a texture, then I'm going to create a frame buffer so that I can render into the texture. I have already done this over here. So instead of doing it here, I'm going to do this here, right? In order to render into a texture, we are doing this. And we're doing F using frame buffer. That's what we are returning. And over here, we are going to borrow the texture mutably and do that. Okay. Is that going to work now? All right, so when we're polling the inner future, the future that we're transitioning into, we're using the current buffer. We determine what size should be the texture that we are going to render into. We make sure that the texture has this size, and then I'm going to over here set the texture that we are rendering into as some ref cell. So this means that we're rendering into a texture, right? Into some texture. Since, yeah, so this means that the texture, even originally, even over here, I guess, must be inside the ref cell. Okay. Must be some ref cell specifically, because I want to have a reference to this. This is a little annoying. You're right, but okay. So have a ref cell. This means that if texture borrow, if texture, and it's because it's inside an option, if texture as ref borrow size is not this, then we do texture as mute unwrap borrow mute Hold on. I can just do get mute, right? Yeah. So I'm just going to replace the current texture with a new texture. And then over here, I'm going to set the texture that I'm rendering into to be in this texture specifically. Okay. Now to have texture as mute, we need to do mute here. Okay. Can borrow intro as mutable because this was not declared as mutable. Okay, so we do over here also this is mutable. Okay. Hold on. Am I compiling? It looks like I am compiling. All right, so here we go. What does this mean? This code that I have written, right? This means that whenever I'm polling the future, this future represents a game state, right? Whenever I'm polling the future, since this is a game state, this future can render something, right? So in order for this future to know where to render, this code is going to use the function, this function with current frame buffer. So this function knows where should we render into. Are we rendering into a texture or are we rendering directly onto the screen, right? So this is implemented using the scope thread locals, and yeah. So this way I can render into something else. So this texture is over here. This is the future, and then we need to like run the actual transition. So what does this mean? We're going to do while not transition finished. So while the transition still needs to happen, I'm going to be So the thing is over here also that we have two things here, right? We have the transition itself, which has a limited time, right? We have this thing finished, and we also have the future, which represents the game state, and the game state can be finished because, like, I don't know, we exit the game, for example, right? So this means that running the transition is kind of like, so the transition itself is also like a future. So we need to basically run them simultaneously, which is like selecting which future returns first, right? So it's either the game state that we're transitioning into is exiting first, or the transition finishes first. So if the transition finishes first, then we are going to, like, until it is finished, to render the transition, and then just give the execution back to, like, directly into the thing that we are transitioning into, right? And if this finishes first, then we just finish, and we don't even draw the transition to the end, right? Does that make sense? Does that make sense? It's almost like I'm going to just draw this ball function. Like more code is going to be written here inside this ball function. So I'm already saying that this thing that we're transitioning into should be rendered into a texture, right? And then we want to use that texture and compose. Hold on. I am even. Should I? No. It's I don't even like always want to be rendering into a texture actually. Something else. Like this logic should be somewhere else. Like the logic of me, for example, making sure that the texture that we're rendering into is the same size as the frame buffer. This feels wrong. I feel like whenever my game state is calling this function with current frame buffer, we need to be able to provide a hook for it, because yeah, like look over here. In order to draw the transition, we need to know how to draw something that we're transitioning from, and we need to know how to draw something that we're transitioning into, and then the exact details are what we're rendering into is going to be like it should be the implementation detail of the transition itself, right? So I think this means that whenever we call this function from within the thing that we are transitioning into, we are going to call the draw function of the transition. And as an argument to this draw, we're going to give the current the function that I have passed as an argument here. That's right. So I'm going to change this again, I think, because I want to, yeah, because it's my thread local. I need to store. Yeah, basically it's like we have this. If we are talking in terms of the effect system, right? We try to implement the effect of rendering, right? So I need to provide a handler for the rendering effect, right? My rendering effect looks something like this: trait render, or like yeah, render. It's literally is with frame buffer, right? So we need to provide the interface dynamically, right? So yeah, I think we need to provide this functionality dynamically, which means that I need to store here actually this thing, right? Yeah. The reason I didn't do this is because I want this thing to have a lifetime, right? Maybe I can make it work with statics. I don't know. Okay, let's try it again. Let's try it again. Let's make it an optional. Or let's just do this if it's set or not, because we have in this crate the ability to scoped TLS. We have the ability to see if it is set or not, right? So that is the thing. So I say if frame buffer texture now let's call this back frame buffer. If frame buffer is set, then we do one thing, otherwise we do another thing. Yeah, over here we do window with frame buffer F, and over here we're doing frame buffer with frame buffer. I wonder, can I get Twitch channel points from Rust? Huh? What does that mean? Once you get affiliate, you get the channel points on your Twitch channel, if that is what you mean. What do you mean from Rust? Probably this should be called with frame buffer. With frame buffer. With frame buffer with. So this is basically like with frame buffer, right? With frame buffer. Right here we do with frame buffer. Hold on, no, this is wrong. Hold on, with frame buffer. This should be a function that as an argument takes a function, right? Oh, and that function as an argument takes a frame buffer. Does that make sense? I think that's what I need to do. And we use dynamic dispatch. All right. So this with frame buffer, this is a function that as an argument takes this thing. Yeah, okay. So over here, with frame buffer, I'm going to call this with a suitable reference to something that takes a frame buffer actually and calls our function with this frame buffer, right? I can listen to redeems from Rust, but I want to gain channel points for some other events like winning a snake game in chat. No. The way channel points work is only by watching, and like you cannot give channel points to people. That is, the functionality of giving channel points is built into Twitch. So like unless you build your own channel point system, which is something that actually people did before channel points existed on Twitch. So like you can have your own fake points, and then you can give those to people. Yes, like stream avatars, for example. If you have this extension, so you have like stream avatars currency, for example, that is separate from Twitch points. It's like similar thing. Stream elements have loyalty points. Well, yeah. It's not a flaw, it's like a limitation. It's okay. Okay. And I want, so since this is a function that I want to be able to call potentially multiple times, but this needs to return. To this, let value is ref cell new none, and over here I'm going to say value just none. Just make it mutable. I don't think I need to do this, so I just do value is some of a frame buffer, right? Does that make sense? And then I return value expect lol. You can still do point runs. Sometimes has betting on things like WOP. You can win points. Well, that's a different thing though. Like that's also a built-in functionality into Twitch, right? You cannot just give points to people. Nautilus, hello, hello. So it looks like this works, right? So is this actually going to work though? Let's see. It looks like I've changed this code like 3 times already or something. So what am I going to do? Yeah, my transition. Transition is something that knows how to render itself if it knows how to render the other thing, right? So whenever my future is going to render itself, it's going to call that function to render, right? So I can store a hook inside this scoped thread local. So whenever we are rendering from inside this future, we are going to render the transition. So the texture is actually, yeah, the texture is not even, we shouldn't even be working with textures here technically. That is the responsibility of the transition itself. Does it want to render into a texture or something else? So this is also not necessary. This is also not necessary, right? We just do frame buffer. Just do with frame buffer. Going to set this into a boxed dynamic function. Yes. Box new. With frame buffer. So over here, basically, we need to do transition dot draw, right? So so this means that whenever this future is going to draw something, we're going to, instead of drawing into whatever we were drawing before, we're going to draw the transition, right? To draw the transition, we need to know what, to know like both things. So the thing that we were transitioning from and to, right? So from is going to be from draw, and to is going to be with frame buffer. I think this is it. I think this is it. And then we set, and then we call into as mute all context, right? So we're polling the future with the frame buffer handler being changed. That's right, and now we have some lifetime issues, no? No, we have something else. Mismatch types, because this should not be here. And then over here, mismatch types, expected reference boxed dynamic FN, but found boxed closure, right? Can I say over here that this is as box din and mute? Hold on, so this is a mutable dynamic function mute frame buffer. Is this it? So what do we want here? Want box. Box to din FN. Mute din FN mute ugly frame buffer. So that's right. Expected reference to the boxed but found box. What do you mean? Okay, there you go, there you go, there you go. An argument of type mutable frame buffer is missing. Transition draw. In order to draw the transition, we know how to draw both things, and then we provide the actual frame buffer. Yeah, so okay. So over here, right, whenever we're polling, we want to also know what is the current frame buffer, right? So we literally call the function that is called with current frame buffer here, the same function that we're overriding. We're still going to call it here with current frame buffer. So over here, we're going to have actual frame buffer, you know? We are going to draw the transition onto the actual frame buffer. Right? So the transition is going to be drawn onto the actual frame buffer. And the window also needs to be here. All right. Expect a closure that implements the FN create, but this closure only implements the FN mute. Yeah, so the reason it's implementing only the f and mute is because we are having this window here. I mean, this actual frame buffer. This is a mutable reference, so in order to mutate the mutable reference, we need to this closure over here is only f and mute. So I want to have actual frame buffer inside a ref cell, I think. Ref cell new actual frame buffer. So over here, I'm doing actual frame buffer, borrow mute, and take a mutable reference to that. Does that make sense? It only implements the ref mute. All right. So the closure that implements the fn trait, but this closure only implements fn mute. This closure implements fn mute, not fn. Closure fn mute because it mutates the variable transition. Oh yeah, that's right. Transition is another thing. So not only the frame buffer is what we are mutating, but also the transition. So we do the same thing. Transition is a ref cell. Transition. So transition borrow mute draw. And then we also have some other issue, I guess. Closure is fn mute because it mutates the variable from. Okay, this is the other thing. True. From is also going to be a ref cell. I probably can like make all of those into one ref cell instead of 3 ref cells because that's going to make me 1 check instead of 3 checks. But whatever, I don't care. For now, let me just have something that works, please. Okay, and then we have the lifetimes issues. I can't bet on Twitch polls. It's forbidden in my country. Yeah. I have heard other people saying the same thing. Even it's fake money, it's still betting, basically, is what some countries think. Okay. Maybe what I'm trying to do here is like something that is completely impossible here. So the problem is that the things that we move into over here, right, are not static lifetimes. Specifically this thing, right? The actual frame buffer, transition, and from, those are all not static lifetimes. So this is still again the same issue. This is again the same issue. Like, do I use some unsafe code here? Because this is literally the limitation of this crate, right? Scoped TLS. If I use unsafe, I think it's actually safe. The way I'm going to use it. Lifetime static required. This is the issue, right? April 20th. This was not addressed. Issue opened in 2021. Is this scope even... is this crate even maintained? I mean, kind of a little bit. It was first made 7 years ago. there another implementation? Scoped thread local storage Rust. This one is from Servo. I think this is the same crate though. Exactly. Scoped TLS HKT. What is HKT? Higher kinded types? This module provides the ability to generate scoped thread local variables in this sense. And then higher kinded types. Oh shit, this is okay. Yeah. So this is what they did here. Reborrow. What the fuck? So you have a static that has like, so you have a generic static thing. Maybe this is what I want. Is this crate good? Repository. It has 7 stars. This looks like what I want. Better than 0, ship it. Hello there. What are you doing? I'm doing the same. Are you the one that told me that you have the same trick that Tokyo does? That's what I'm kind of implementing right now. So like my when I'm running, so my game engine is the executor for my futures, which is representing my game state, right? And one of the features of this executor is the thing that we're rendering into, and I want it to be like uh yeah, you know. I want to sometimes substitute it so that I'm not rendering directly into the window, but into a texture. So I'm trying to do this scoped thread local storage trick here, so that when I'm polling this future, instead of rendering into the whatever we're rendering before, I'm rendering into something else. This looks nice. The API here, I think. Okay, let me try using it. How much unsaved do they have? Reborrow mute. Trait represent the act of reborrowing a mutable reference to produce a new one with a shorter lifetime. Nice. Nice. A lot of macros. So I'm guessing you did not refactor your thing into standalone crate, so. But I actually want it now. Looks like this is the closest thing so far. So this literally is the same as that other crate, but it allows me to have the lifetimes that are not static on this thread locals because they are scoped. So that scope is going to be represented by that lifetime, right? Is what I want. All right, let's try using it. You didn't yet. Maybe you can use this crate. You can review it also instead of making your own. Thread local. Oh, hold on. Scoped TLS. Okay, scoped TLS is going to be version is 0.1, I think it was, right? And package is going to be scoped TLS HKT. There you go. I'd like to see the scoped TLS HKT. A more flexible version of scoped TLS. Yeah. Storage of references to dynamically sized types. Oh, nice. This is exactly what I tried before. Storing references to dynamically sized type. Yeah. Just wanted to see, yeah, the discussion of this. What did people say? Just published a new crate scoped at TLS HKT. This removes several of limitations that were frustrating me with scoped TLS. It's now possible to have scoped thread locals using references to dynamically sized types, mutable references, types containing unbound lifetime parameters, hard-coded types, some combination of the above. For example, using all four together. Yeah, so like, yeah, nice. Are you sure this is sound? I had a quick glance. I couldn't see if you stopped recursion. How do you avoid this? Undefined behavior, two mutable references to the same variable. True. Good question. HKT is implemented separately for immutable versus mutable types. First of all, your code will not compile because scope thread local. This means that you're using immutable variant, which requires the contained type to be copied. However, I assume you're asking about the mutable reference, which would be defined like this. The code generated for the mutable variant instead has a reborrow mute trait bound, which allows mutable references. To ensure this is sound, foo mute takes the value of the thread local for the duration of the block. Takes the value of the thread local. Nice, makes sense. So the second nested usage will panic because it's not set. Okay. That makes sense. Submit BP pull request to Twitch. Yeah, in order to submit the pull request to Twitch, you need to get access to the Twitch source code, which probably means that you need to get a job at Twitch. True. True. Their source code is not open, right? Pretty sure. There's nothing open about Twitch. Okay, scope TLS HKT. Seems like a nice crate. Seems like a nice crate. Let's try using it. Cargo run. You search for certain code leaks. Yeah, maybe in the code leaks. So this means that with this new thing, the scoped thread local, I can, for example, instead of boxing, I can literally store a reference here. Is that right? Or wait, hold on, not store a reference. I can store a dynamically sized type, which means that I can just store the dynamic function directly, right? I think in this crate. So this is what I can do. Not that it changes much. But the biggest thing is that this dynamically, this function needs to have a lifetime. So we have a lifetime here for this dynamic function object. So I need to have a for a here. If I understand their thing correctly. Huh? Okay, fine. Let's do a boxed in trade object. So this is what is fixing it. This is no longer a static lifetime. It's going to be bound when I'm setting it, right? Method get exists for reference cell option box dnfn. Oh, this requires this to be copy, and this is not copy. All right, hold on. This crate has a different API, I think. We're storing directly the reference here. We're storing directly the reference. So that means that it's going to be a reference. Like that. Use parentheses to disambiguate. Like this. That's what we want. So I just done the box here because it's not needed. That's right. Variable moved, yes. Variable moved, which means that hold on, but since this crate also allows me to take a mutable, to store a mutable thing there. Least confusing Rust error. Wait, which one? Okay, I'm going to store a mutable reference to this thing, so this is going to be fn mute too on the outside. But this means that it's not going to be the scope thread local, right? I need to let me take a look at this crate again. Scoped TLS HKT. So for a mutable value, scope thread local static mute. I just need to do mute, right? Mutable higher counted types. Static mute for a mutable references. Yeah, I think so. Okay, so we just do static mute. This is invalid syntax. The lifetime should be here. There you go. So now I don't need the ref cells anymore because I can just make this closure the fn mute closure, right? So I don't need the ref cells anymore, and I don't need to do the borrow mutes anymore. By the way, is there what is the shortcut in Helix to select the thing that is equal to the current selection? Is there such shortcut? Because I know that you can select the lines, and then I can search inside here the borrow mute, right? So that I can do this. You know, to delete that. But in VS Code, I can select something and then have like a new cursor which is equal to the current selection. Would be Control D in VS Code. Yeah. So what is the analogy of Control D in Helix? Also, I changed some other code that I didn't want to change. Apparently. Actual frame buffer is just that. Okay, there you go. Look how simple this is now. Nice. Unless I'm going to change this all again. So whenever I'm polling the inner future, I'm changing the current frame buffer that I'm going to actually render into instead of rendering that future into the actual frame buffer. I'm drawing the transition into the actual frame buffer. And whatever this future wanted to render, it's rendering as a part of the transition. Okay, there you go. Okay. But also, I only do this if the transition has not been finished yet, right? So I do this if not yeah, basically if transition finished. If transition finished, then I literally just pull this thing. Otherwise, I do this. Right? So those are the two things. So this means that once the transition is finished, I'm just going to continue pulling the future as it was. And then, so this is over here, I'm creating this new future, and I'm just awaiting this future, right? That is it. That is it. Hold on. Am I done with this function? This function is pretty simple then. And then also I'm just forwarding the events. Yeah. So the only thing now is that I should render into the frame buffer provided by this function instead of provided by the window directly, right? Well, we still have something. Cannot move out of F. Cannot move out of F because this is implementing FN once. Okay, I think we just do let mute F is some F, and over here we do like technically I want an FN once here, right? This I want to be an FN once, but if I want to have a dynamic FN once, then it will need to be boxed. This way I don't box it, right? So over here instead I want to do F, take, unwrap, like that. Value expect lol. Okay, so the crate itself has compiled, and now we can try. Now we can try. Just using that in our example. Space escape. Let us see. Let us see. We don't have a context. We don't. So technically, all we need. I mean, so this means that I don't even need this, right? I don't even need this. Local box future. Run impl. We don't have context anymore. No context. The events are literally getting directly from our window. No context. We might reintroduce it later. So in order to draw the transition, I need a window, right? Self window. But since I need to provide self here too. Okay, well, hold on. Context switch. Oh yeah. So but we need to have context for like for this flow mechanism, right? To do the to have a resumption object. So this means that run. It's like state task, I guess, is going to be a switch resume task. Turn in nothing. Oh shit. Is that right? State task. State task. This be a reference. Okay, so over here, in order to do the switching, we need to have this state task, right? That will allow me to do the switching, and then I do the transition. Transition is going to happen from the window into the resume. This, yeah, and resume is resume with nothing. Okay. And then over here, so with frame buffer. With frame buffer is going to be this freestanding function, async, again, async state. What was this function called? With current frame buffer. Should just call it with frame buffer, technically, I think. And this needs a window. So maybe this should actually be, I don't know. We'll see. Self window. Self draw. So should I clone the window here? Or is that not while we are already borrowed? Or is this what you're talking about? Can I move out of self because it's also borrowed? Can I move out of self because it is borrowed? State task lifetime 1 appears in the type of state task. This be not implicitly elided lifetimes are not allowed here. Okay. Disallowed. Okay. We need a little bit of lifetime solving here. Cannot borrow self as mutable because also borrowed as immutable. Immutable borrow occurs here. So yeah, the resume. The resume. In order to have the resume, I think I need to move everything there, right? And instead of having self window, I need to not move self here. Like technically this. No, this. Yeah. I cannot move self into this closure, which means that from self I'm only using the window. So I can just do window is self window clone. Expected task found window number 410 window. Yeah, so over here we are running the game stage, so we need to provide like the switchable task. So we do switch resume run task. I mean, technically it can be wherever, right? Technically it can be whenever. I can like do switch resume run state task sync move. That's right. So over here I give it a reference to this state task. Okay, that's one issue solved. And now we have one more. Explicit lifetime required for the type of state task. Why is it required to be explicit? Explicit lifetime required in the type of state task. Add explicit lifetime. Okay. Pretty sure it should not be the same lifetime, right? I mean, if I do A here and I do A here. Okay, well, I mean, fine. Let's do what the compiler tells us to do. And then it says that window doesn't live long enough. That's not actually the thing that I want to do. I'm pretty sure. These lifetimes should be different. Maybe it should be a B lifetime. Here. Hold on. Like, it's an independent lifetime. Lifetime may not live long enough, so we need to have A is B. It is not true though. So why do we need A, B? So what this means is that the A lifetime is at least a B lifetime. So this is required because of the switch function, right? So I don't have lifetimes. I don't have correct lifetimes here, maybe. Let me think about it. I'm switching the execution of the current task to this, right? Hmm. Maybe they are right. Maybe they are right. But if all the lifetimes are these, then it means that, like we have seen before, it means that the window does not live long enough. And it does make sense, but I think this means that the switch resume task must be done in a different position. Specifically, I think it's going to be done directly over here. I'm going to do switch resume. So yeah, switch space escape. This specific thing that I'm doing is going to be switch resume run task. Oh, yes, task sync move. Well, just that, I guess. This requires the state task is borrowed. Okay, fine. Async move. And we await this here. Can it move out of window because it's borrowed? Window is borrowed, but I can just clone it. And I can just move it into. A renderer does not live long enough. And the window does not. Window still does not live long enough. What? It's literally like has a static lifetime at this point. Huh? Okay, I think I know. I think sometimes like the async closures they are not like smart enough. Async function run. So I'm going to need the window there. I'm going to need the renderer. And I'm going to need the state task. Going to be switch resume task. So Okay, I see. Okay, I see. There's a renderer. This is the renderer. I make renderer. So yeah. It looks like right now I only know how to do this with like static lifetime. So I need to space escape. I'm just going to not have a lifetime here at all. So instead I'm just going to do a reference counted renderer and the window is already reference counted inside. So just like this. We don't have a lifetime on this anymore. I think. So over here, it does not matter anymore then, right? I just do anonymous lifetimes. Well, I cannot because I have these futures. All right, like that. Renderer is going to be self-renderer clone. Okay, fine. Crossfade new. Can I do this? Not sure. Active state for the space escape. No. And borrow self as mutable because also is borrowed as a mutable. So right now I'm borrowing the window here at the same time as borrowing self as mutable here, right? Because in order to draw, we need the mutable self. Yes. So this means that I just do I think I just clone this here, and then we don't have this as a problem. Yeah, over here I also do window clone. Wait, hold on. What do you mean? Self moved value self window. Where am I moving the self window? Over here, obviously. I'm going to clone here. I'm going to clone here. Alright. And we have so the into is just the future, so this does not need to be mutable. Makes sense. Immutable borrow occurs here and mutable borrow occurs here. Okay, so we need to clone here. All right, just a bunch of clones to make everything work, right? Mismatched struct expected this, found this. So renderer, I'm going to create it with reference counting. There you go. Space escape new renderer. Mismatched type. Oh yeah, this is going to be a reference counted. Right? Okay. Is this the last state task does not leave long enough? Why does the state task not live long enough? What do you mean? Hold on. What do you mean? State task does not live long enough. Borrowed value does not live long enough. Argument requires that state task is borrowed for 1. Lifetime 1 appears in the type of the state task. This thing is 1. Okay, I understand. I think I understand. We now have this problem that this lifetime is the same. I think we just remove this generic and make this actually simpler. Replace this. Oh, wait, hold on. I cannot, right? I cannot. Okay, fine. What if I just do this here? This is going to compile. We only have warnings now. Okay. And over here I do switch to resume run, and I am running this function. Function is expected to take 1 argument, but it takes 3 arguments instead. Okay, so we have a task, and we do run using window renderer and task and reference to the task. Task does not live long enough. Okay, so close. So close. All right, let me take a quick bathroom break. Oh, Kuviman, what camera are you using? It is called the Ryzen Razer Kyo. Razer Kyo. No, this one. Hello there. Welcome to the stream. Take a break. All right, we are back. All right. A little bit of lifetime issues here. Okay. So yeah, I wouldn't say that I necessarily understand these things here. So I'm running this thing. Why does my task even have a lifetime in this grid, by the way? Hold on. I have tasks. Why does this have a lifetime? Oh, yes. Hmm. This argument requires the task is borrowed for one. True. True. True, 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 true. Does this mean that I should... Hold on. No, 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 no. This is what I want, right? I want a reference to the task. This lifetime should not be... I don't know. Why is this so hard? Why is this so hard? Hold on. Will this work? Will this work? Explicit lifetime required for the type of state task. Lifetime A required. Yep. I mean, I'm almost at that point that the only lifetime is this, so like I can make it a static lifetime because I'm not like borrowing anything at this point, so... The problem is that I will want to do that, right? What exactly is the error message right now? It says that explicit lifetime required in the type of the state task. Lifetime A is required because we cannot return a value referenced in the function parameter task. Task is borrowed here, and this returns a value referenced in the data owned by the current function. Can I turn value referencing function parameter task? We have two errors here. What does this mean though? Explicit lifetime required in the type. Why is it required? Cannot return a value borrowing function parameter task. I think I know how to fix that though. Like this over here is because I need to do an async move and await this thing. So this fixes that issue. Because if I don't do an async block and await here, then it means that yeah, because the future returned from running this function is borrowing from, yeah. Okay. So now I'm left with just one problem. Explicit lifetime required in the type of the state task. Why? Why? So if I do another explicit lifetime B, so like for example over here, it's not required, right? The definition is the same. Right? Okay, actually, hold on. The inactive state. Right now, this is not even having any references to the task itself. So this does not need to have this lifetime, for sure. Does it? There you go. There you go. So this does not have the same lifetime. And then we have the lifetime of the future that is returned by this run, because this is basically the recursive async function here. Can I have this one like that? I can. I mean, that's the same thing. Okay. I have the same lifetime. No, I already know that I cannot do the same lifetime. It's because this is an async. Yeah, I see. So this is an async function. This is an async function. As an argument, it takes the staked task, which is a reference. This should live for the same lifetime. Obviously. Can I just do underscore here? No, I cannot. Because we are not saying what this lifetime is coming from. This I cannot do. This is the wrong definition. This is the wrong definition. So the difference here is that I'm taking it without a reference. You're back satisfied with your caffeine addiction. Nice. I am still here, fighting the borrow checker apparently. You know what? Before doing this, how about I just don't do that. Run. Is there a shortcut for me commenting out this argument instead of the entire line? I want to comment out only this argument so it doesn't exist. Maybe I can surround it with a comment. Surround with slashes. No, that's weird. I mean, almost. I mean, hold on. I can surround with slashes. Hold on. No. I surround with star, and then I surround with slash. And that's how I comment. Right? Is there a better way of doing this? And over here I do the same. Surround with star, surround with slash. There you go. I don't have this, I don't have that. So now this, like, this future is like literally having static lifetime now. So I made it much simpler because of that. I'm thinking that this create. What do you mean? Missing lifetime specifier. Isn't this defaulting to static? Okay. Okay, I just comment this out because this is the transition into the continuation. I'm not sure if I can. I need to see what is continuation, how to fix this. Okay. Is this it? Is this all? This should work, right? Cargo run. I am unsure. What have I done here? Let's try. Well, we panic, obviously. Nice. And the problem is that we have entered unreachable code instead of switch resume crate. Nice. Very nice. What if we don't use that crate yet? Okay. Hold on. So this actually works. Look at this. This is actually nice. So this actually works. As so that's the first part of it, of the thing, right? So I'm actually doing the transition right now into the other thing, and while this transition is happening, I can still interact with the thing, so I can have multiple transitions happening at the same time. As you can see, if I just spam space, we can see like multiple triangles being drawn at the same time. This means that, like, yeah. But then when we're going back, when I'm pressing escape, I don't have the transition anymore. So the reason for that is because when pressing escape, I'm going back and I want to do the transition into the continuation, right? And this is the part that I'm struggling with here. So I'm trying to use this create of my own that allows me to do the continuations, and apparently it's not that easy to use. I have some lifetime issues. Not only the lifetime issues, why am I panicking here? I'm entering the unreachable code. This unreachable code means line 74. Line 74. This means that I was trying to receive. Oh, yeah, okay. Yeah, okay. It means that I dropped the task. Okay. I think this should not be unreachable. This means that yeah, this was disconnected, so I just dropped the task. That is okay. That is totally fine. This is not unreachable. I should just not do anything here. It is the same as the empty. Yeah, like all the errors are. Yeah, okay. We just, yeah, right. Okay. I need to use a patch though, is what this means. To work with that crate, because at least it's a different repository, right? Let me for now just edit cargo toml, and let me for now have this crate to be a path dependency. Path is going to be switch resume. Is that right? Cargo check. Project switch resume cargo toml. Because it's still called Rust effects here, so I need to move Rust effects into switch resume. Okay. This means that I can work on that library. I'm going to open switch resume source lib. So this unreachable that I have here, this literally is not even unreachable. Obviously. Or async channel try error closed. So like both of these errors, I'm just going to explicitly list them both. So even if we are closed or if we are empty, we still need to just continue working. Just as a regular async function, basically. So now if we run this, this is just going to run as a regular function. No, we are not responding. It's not even running. Okay. So this means that my crate is even... Yeah. Okay. I think instead of a loop, you know what it should be? It should literally be just std future call fn, where we have the context and then we await over here. Yeah, so if we receive the ready, then it is ready, and if we are pending, then and we just return the pending. Hold on, and then we're going to wait for the waker automatically. So this is like just a regular one, and over here we're pulling this using the same context. So like, yeah, okay, hold on, just do this continuation. So this is just literally doing nothing, and I'm just returning all pending here. And I need to move. No? What do you mean? Can't move out of the continuation. A captured variable in an FN mute closure move occurs because. But why could I do this before, by the way? Okay, fine. Let's do option. Continuation is going to be equal to sum switch continuation take unwrap. And over here we do continuation as mute, unwrap as mute. This is ugly, but at least the compiler doesn't complain, right? Okay. So now basically my create all works with existing async code. So this just works. Okay, nice. So now the problem is async example. This one. So now the problem is that I want to use the switch functionality, and we need to figure out the lifetime here. So what is the problem here? Does the reference have to live for the same lifetime here, right? Okay, what if I take this by value? Yes, we have the problem here that lifetime may not live long enough. Return this value that requires that this anonymous lifetime not live static, because I'm doing the static lifetime here. And this is also okay. This is not static lifetime, obviously, because we're taking a reference here and we're holding on to that reference. But they should not be the same lifetime, they should be different lifetimes. Pretty sure. And then which lifetime should be bigger? The A lifetime should be bigger, so it should be A, B, right? Hold on, am I compiling? Hold on, I am actually compiling. Oh wow, look at this, the professional lifetime solver. Solve the lifetimes like it's nothing. Alright, there you go, there you go. Cargo run. Well, I'm not using this thing yet, right? Like the state task, this is unused for now, and I need to use it over here. So I need to like do the transition into the continuation, right? And it actually compiles still. It actually compiles still. Wow, hold on. Is this actually going to work? So I'm pressing space and I'm crossfading into the different triangle, and then I'm pressing escape and I'm going to crossfade back. Oh shit, this actually works. So I actually did what I wanted to do. And we can do like so we have two transitions actually. We have crossfade and we have the swipe transition, right? Yeah. We have two transitions. When I'm pressing space, we're going to do the crossfade. When we're going to do escape, we're going to do the swipe, which looks like this. It's a little weird when I do like exit multiple layers at the same time, but okay. I think I actually know why. Because over here I'm pushing into the state, so whenever I'm so I want to create a new task basically here. I am pretty sure. So that the thing that I'm transitioning into. It's going to be a new task. So it's going to be switch, resume, run. So having the task here, do an async move. This is the new state task, right? Reference to the state task. Wait. Like that. New active state is not implemented. Yeah, because we need to do this, right? Expected this to be a future that resolves into nothing, but it resolves to the box. Expected this to be a future that resolves to a unit. Why did we expect it to be resolved into a unit? Oh, because over here it resolves into a unit, which means that I actually need this to be generic over the return type of the task, right? This type parameter. What's wrong with this type parameter? Okay, true. I just don't do a semicolon here. Okay, over here I don't do self, I just do window, renderer, depth +1. Because I need to not move self into this closure. Self window clone. Okay. So I need to make this a move closure. Okay, is this done? Okay. No more errors. Probably means that it's going to work. First try easy. Okay. Does it still look a little weird? So I think like the space key works really nicely, but when I do the escape, like if I wait for the transition to end, then it's okay. But if I do the this thing in the middle, so it kind of like exits that other transition immediately. Does it? Like I So why am I immediately stopping the previous transition? I mean, this already is what I wanted, but I want to go forward like this to have like 3 transitions shown at the same time, and going backwards I want to be the same, but I'm only showing 1 transition. Right? What happens if I... What happens if I move all of those over here? Why are we not being formatted here? Why am I not formatting? Cargo FMT. 319. Oh yeah, semicolon, sure. Okay. So this is moved. I need to clone it. Is what it means. Value moved into disclosure. In the previous iteration after which value? Oh, self, probably self, yes. Probably self. So over here I want to draw this transition. Can I do let this is mute self? And over here I say that it is this. Okay, it's not self window, it's going to be this window. Okay. There you go. Oh wait, hold on. There's still mismatched types. Oh, this is in another example. Okay. That is alright. Ah shit, now nothing works. I'm not drawing the transition at all. Okay, hold on. Instead of like trying to do random things, what do I want here, right? So when I'm doing the transition forward into something else, this is very simple because I'm not using any like continuation shit, right? What happens when I press escape 2 times in a row, right? It means that I like over here. It means that I'm exiting from the inner state. I'm using from the initial state. I'm transitioning into the continuation, which makes sense. But then I press escape a second time. Oh, I understand. I actually understand. Actually understand. So whenever I'm pressing escape, basically what it means, I'm breaking the loop here, right? This means that I'm stopping rendering the current transition. If I was like rendering it, I'm just breaking and doing nothing. So that all makes sense. If I want the same behavior on the escape, it means that I need to return. So it means that when I am returning from this function, the active state, this should like return what should be returned? It's almost like the current continuation should be returned from this function. You know? Anyway, I think improving this even better is an interesting task, but I have achieved what I wanted. Actually, I have actually achieved what I wanted, right? I can do a transition into a state that I can interact with now. Right? Yes. I actually did it. Oh, hello, Bad Cop. How are you doing? Are you going to stream anytime soon? By any
Hi.
chance? I'm going to bed. Okay. Well, good night, Bad Cop. Hmm. Okay, well, let me commit and push and publish the updated crate. So this is going. I guess since I want to publish it, I will also update the version here to 0.1.1. The API is the same, just like I fixed a bug, I guess. Okay. Fix dropping task and working in any async contexts. There you go. Click publish. Okay, so this is done, and then over here, I am going to. Well, hold on. Cargo toml path. Switch resume this one. So this is going to be a dependency from the crates.io again. Cargo update. Cargo update, switch reset. Only this one. Switch resume. Ah. Wait, what? Package ID specification switch resume did not package any packages. This doesn't make any sense. What is my package called then? What do you mean? Cargo lock. Switch resume. There it is. I have a switch resume package in my... I have an MMO rated me instead of you. What do you mean? Were you live today while I was streaming? But he rated you while you were offline. Switch resume versus switch resume. No. Maybe he saw you in chat. Hello, Arya. They are fishing in your chat. Nice. You can join them. I'm conditioning you? What do you mean conditioning? Anyway, what is this error that I have here? I have a switch resume, a package, right? Why can I not do cargo update of it? I don't understand. Cargo update, switch resume. This did not match anything. Bad cop is rating. Wait, what? Wait, hold on. What? What? So you could raid me? Wait, how does this even work? So you were offline, you were raided while you were offline, while you were not streaming, and then you raided me while you were not streaming, and you have some viewers. I guess so, like, just the people that are in your chat are considered as viewers? Is that how it works? Which doesn't make any sense. Alright. Hello, Evan. How are you doing? Is the number of viewers and the number of chatters the same thing or different? So like if you watch without video, if you only like open the chat, are you counted as a viewer then? Is that how it works? Easiest raid of my life. Well, thank you for the raid, Bad Cop. If you guys don't know Bad Cop, you should follow Bad Cop. Bad Cop _ there you go. Let me give you a shout out. Thank you for the raid. If you watch without video, you are the viewer. How have you never known you could raid offline? So weird. Well, I guess it's because like people can hang out in your offline chat, and then like you just hang out in your offline chat and you raid someone. You know, it kind of makes sense. You know, you don't need to need to have video in order to have some action in your chat, right? Package ID does not. Hold on. What is my problem here? Cargo update. Why can I not update one of the packages that I have as my dependency? So like I can only update everything? Is that what it means? Or wait, hold on. Ah shit, well, too late. I updated everything. Whatever. Now we need to recompile everything is the problem though. That's why I didn't want to do this.
Hello, Bad Cop.
Now we need to download 12 crates. Yeah, there you go. Switch resume is there. Aria, thank you for the raid. How was your stream? Oh wait, you weren't streaming. That's right. Now you will have a lot of raids. Well, technically I can disable raids from... I can disable raids, right? I think there's... I mean, can you guys stop spamming the raids? Who is the second person? Someone went into your chat. Someone just really wants to fish, I think. Stop spamming raids, spam hello rings. I mean, you know, I can disable the hello rings too. How about just don't do anything that is annoying, huh? There you go. Do a jump scare for a change. Okay. So technically, the thing that I did is working. So I can do the transitions. And I have this continuation mechanism. They are completely separated from each other. Async state transition. Better async state transition. There you go. So this is better, but this is not perfect yet because I did it with static lifetimes. It's not always that I have static lifetimes. I mean, can make everything into static lifetimes. Spam pull request for all version of link cider, so Kobe will see what he was doing. Something can be done a lot faster. How about you don't spam anything? Like, spamming is bad. How about you don't spam anything? Otherwise, I will start spamming the bans. You know, I have the power to do the banning. Okay. I can make this into the link cider now, I guess, technically. Let's go into the link cider. Let's do cargo update. Here too. And now we can use the same mechanism for the link cider. Maybe, potentially. I'm not sure. I'm not sure that I can do just static lifetimes. Okay, so we don't have this. We do not have this. We do not have this. Yeah, so we have these transitions. In order to do the transition, I do need to do the to do that, and I'm going to transition into this state. I'm going to transition into the state run. Like that. And then we have the errors. So over here, I'm doing more transition. So this is like exactly like the code we had before. Let's comment out this transition. This requires a continuation. This one is pretty simple. Context window. I'm moving self into over here. I literally into state run. And I'm literally saying transition and mutable state with this instead of that, right? Okay, so this should be now a better version for the link cider. When we are going and when we are transitioning into the inner state, I can interact with the inner state immediately, meaning that I can like exit it immediately, for example. Why is this waiting for the file lock? It's because okay. Hold on, I have two background tasks right now. How does this even work? Can I go foreground 1? Okay, so over here, we're going into, and there's absolutely no transitions anymore. Why? Why is there no transitions? You really like that loading screen? Yeah. Loading screen is pretty nice. Boom, boom, boom. Code is inactive due to CFG directives. Feature editor is disabled. Yeah, makes sense. State variable doesn't need to be mutable because I'm running it. Yeah, just doing this. So I don't understand. I'm doing the transition into this inner. Stuff, right? And I'm not sure why am I not seeing the transition right now. This transition, by the way, should probably be renamed. This transition. What is it? This transition even is like going next previous level editor. To do keg W. It is. Oh wait, hold on. I know exactly what the problem is. I need to not use rendering directly into the thing. So I need to search. I need to do a global search window. I guess just with frame buffer. With frame buffer, generally, it should not be done. Instead, when I'm doing shit, like doing a loading screen, for example, it should not draw into here. It should instead be getting async state with current frame buffer, right? With current frame buffer. Getting async state with current frame buffer. Self gang window. Like this. Draw FN. Draw FN is that. Yeah, okay. All right. I mean, this should just be everywhere. Just window with frame buffer should not be used, right? Yeah, so like same over here, it's going to be getting async state with current frame buffer. Self context window. Over here we do frame buffer. Self draw. Just everywhere. The pop-ups, like everything, should be using this new API. I will probably move it somewhere else, so I will change it again. Is there a global search and replace in Helix? Because that is what I'm doing right now. That would probably be done faster. There's a global search, but not global search and replace. I understand right now. Okay, this is the last one. Okay. I think this is it. Sure that I should now see the transition again. Okay, there you go, there you go. So now, unlike before, I can interact with the state that I'm going into immediately, instead of waiting for the transition to end. Which is nice. Now I don't have the transition back. Alright. So in order to do the transition back, once again, we need to work with the continuations, right? Play mod over here. I need to add as a dependency here. Add as a dependency, I am adding the switch reset, switch resume 0.1. Okay, there you go. Then we do play mod. Where is it? Over here, right? So this is the thing that I have commented out. In order to do the transition back, I need to transition from here into back into self. So like I'm not transitioning into self, I'm transitioning into the continuation of the current function, right? Which means that I need to do shift. No, not shift. I'm always trying to call it shift reset, but it's no longer a shift reset. Okay. You know what? Let me just do this over here for now. Switch, resume, run, task, async, move. Okay. Wait. Okay, so now this task that I have, I can pass as a reference to whatever needs it. Specifically, I need the handle event over here. It's a reference to the task. Right, so task is going to be a reference to switch resume task. Ask something like that. Yes, it just whatever. I think it should be a generic thing. Like that. So I can over here use this task to switch into, I'm going to switch into the transition, right? So I have the resume, and I'm going to switch into resuming with this. And now we're trying to return in a ref temporary something. Do I move here? Can it return value reference and temporary value? What am I referencing? Am I referencing the resume? No. Can it return value referencing local data ctx gang? That ctx is ctx clone. ctx gang is borrowed here. Okay, yeah, you are right. Let's just do an async move. And then we are going to await this. So this should be fine. Yeah. We're compiling. Okay. So yeah, this was pretty simple. I just use the continuation and I'm transitioning into the continuation. There you go. So is this a good real world use case for the continuations? If anyone was following what I was doing, do you understand what we have? What, like, why? Just have this fancy effects here now when we're going into state, when we're going out of state. And I can, yeah, okay, this is very nice. I like it. The only unfortunate thing is that, like, there is a... Well, I guess technically it's even impossible for me to, like, panic at runtime. It's like I'm dynamically changing the thing that I'm rendering into. I just came back from doing stuff. Well, welcome back. I just made it work. I made everything work that I wanted to do. Look at this. We have these transitions. Be proud of me. Look at this. So we have over here, once again, this is me going into the inner level, right? This is technically our level selection screen, which is undone right now, not designed. So I'm over here going into the inner level. We have this transition, right? Which looks pretty nice. And then I'm going back, and then I'm doing the transition again. right? So when I'm going forward, I'm literally just transitioning into an async function, right? When I'm going back, I'm basically back from that async function, and what I'm following into is into the continuation of the current function. So yeah, I'm actually using these continuations now, and it's working, you know? This is nice. This is nice. So just one more time, I will show. Over here. So like the transition function is literally a thing that takes as an argument a future that I'm transitioning into, right? So when I'm going into the inner level, I'm just like calling, like play the level. So this is me loading this level, and then I'm just playing this level, right? So I'm just like transitioning into playing the level, and then once I'm back from that other level, I'm switching the execution to get my current continuation, and I'm transitioning into my current continuation. So current continuation is going to be rendered into a texture and composed with whatever we came from. This is really nice, I think. This is really nice. I'm not sure if I can come up with a like with an easier example of how would I use continuations, but I'm sure that those exist. All right. Okay. Async transitions. Proper async transitions Borg. There you go. Do I even do anything else? I don't know. I think now that I have the real world use case for this, I feel like I published this grade. Maybe someone else can find usage for it. So I want not only to publish it, I want to like. This is so small too. This is just like 50 lines of code, if you don't count the comments. I guess I need to fix this panics here though that can happen. Whatever this means. I fixed one panic before. This unreachable. This is old code actually, right? We don't have unreachable anymore. So this works with existing async code now. I'm pretty sure. Need to fix then these panics, and then I can tell the world about this library. All right. I guess I did what I wanted to do today. So going to be it for me for today.
Bonus points 4, right? So I'm guessing they're gonna move towards it.
Let's go here.
Lots of Rust jobs, right? Lots of Rust jobs.
Rust jobs.
64 of them, right? But this is just me grabbing
a
job site and searching for Rust.
See tomorrow, I guess.
If you guys search for Rust
or maybe
jobs,
I will
you will find Rust jobs.
later play a game on my other channel, but we'll see.
People definitely want to hire Rust
Anyway, tomorrow I will
right?
continue working on the game, so Until then, bye-bye.
Who would have guessed it would be the next big thing in AI? Glad I tuned in today. No, not the next big thing in AI. The next big thing after AI. Right?